Okay, let's take a look at this other measure of variation called standard deviation. It's the most common one that is used when you're dealing with data that you take averages of. And it's similar, but not the same as mean average deviation. Math that is used to construct it is a little more involved. Absolute values are pretty simple. You just look at these numbers and drop the negative signs, basically. What standard deviation does, it doesn't use the absolute value. What it does is it takes these numbers and squares them. So you take the numbers you got in this column and then square them. So -1 becomes 1, because that times itself as 1. 0 stays 0. 2 becomes 4. -2 becomes 4, because negative times a negative is a positive, just like up here. And then 1 becomes 1. Now, if anybody's sitting there thinking, why the hell do you square? I've got a video in the description of this video, another video that I made a couple years ago, because I thought the exact same thing. I said, what the hell? Why would you square? That seems weird. I mean, when you add this up, this plus this plus this plus this plus this, you get 10. Now, what that is actually called is the sum of squares. That's actually a statistical term, the sum of squares. Sometimes it's just called SS. So if you're ever reading a statistical article and you see SS, it means sum of squares. Why square the results? Not to give too much away, we're going to take a square root later to remove the squares, and we'll talk about why that makes sense later. But what you do now is you take the average of that across all 5 data points. And that right there is called the variance. So the variance is you take the sum of squares, so the sum of those squares, and you divide it by how many data points you've got. So in this case, the sum of squares is 10. You divide it by 5, your variance is 2. Your variance is 2. Okay. Now, that in and of itself, the word variance, or the statistical term variance, is in and of itself a statistical measure. You'll talk about it a lot in Math 244, actually. And it's an important one, because it's actually how standard deviation starts. The problem is, when we look at the number 2, what is the unit on that 2? Well, let's go back to the beginning.
Go back to the beginning.
These were test scores, so these were points on a test. If you subtract points from points, these are still points on a test. If you take points and square it, these are now squared points. That doesn't make any sense. Squared points. So the variance, this unit, is 2 squared points, which makes absolutely no sense whatsoever. So what you actually have to do is take the square root of that to get it back to a unit that does make sense. Now, looking behind me, I'm out of space on the board, so I'm going to have to switch to my other board. So we've got the variance. Is 2 squared points. The standard deviation is equal to the square root of whatever the variance is. So when you're calculating these things by hand, which, by the way, this is the first and last time you'll do that. The square root of the variance, the square root of 2, which is about 1.4. 1.4 what? points. Because remember, the variance was points squared, and if you take the square root of squared points, you're going to get back to points. Now, let's talk about what that means. You've got a standard deviation. The standard deviation is now 1.4. What does that mean? 1.4 points is equal to what conversational measure? Remember average deviation? How average deviation was the average distance a data point was from all the data's average? This is just another way to represent that. It's a different measure that represents effectively the same thing. And you can think about why. If we go back to the calculation that we did, we're still using the same distances. We're just dealing with the distances to get rid of the negatives a different way. Rather than taking the absolute value, we're squaring, and then square rooting later to get to the unit that makes sense. As I said, the video that I've got linked in the description that will pop you out to another video if you're interested will connect standard deviation to average deviation, mean absolute deviation. If you're interested, you might not be interested. And as a matter of fact, you might be exhausted. The good news is I've created a tool to actually calculate these things for you. So let's go into that tool and actually do Ernie's standard deviation using the tool.